Today we're going to solve the limit and continuity. So we have this, determine the limit if it exists. If our limit x approaches to 4, the square root of x minus 6. So what we're going to do is we're going to replace the 4 in the value of x. So we're going to have square root of 4 minus 6 is we're going to have negative square root of 2. So since it's negative, therefore the limit does not exist. So next is we have the limit x approaches negative 10. So we have this x squared plus 15x plus 50 over x plus 10. Then we will change the value of x to negative 10, so it will become x plus 10 and x plus 5. This is the factor form of this, and over x plus 10. So since it's the same, we can able to cancel this and we're left with this x plus 5. So we will replace x to negative 10. So we have negative 10 plus 5. So we have negative 5. Therefore, the limit exists. F of x is given below. Based on this graph, determine where the function is discontinuous. So as we've shown in the graph, there are 3 points, the negative 3, the negative 1, and 1. So since it is not continuous, therefore we can say that these points are discontinuous. We have this number 3. Determine if the function f of x equals 6 plus 2x over 7x minus 14 if it is continuous or discontinuous. So we have this letter a, x is equal to negative 3. So using this given function, we will change the value of we'll change the x into negative 3. So we have f negative 3, 6 plus 2 times negative 3 over 7 times negative 3 minus 14. So we have 6 minus 6 over negative 21 minus 24 is we have 0 over negative 35. So therefore our f of negative 3 is equal to 0. So we're going to see if our limit exists or not. So we have this limit x approaches to negative 3 to the left. So we have the 6 plus 2x over 7x minus 14. We have this 6 minus 6 over negative 21 minus 14. So we have 0 over negative 35. Then our answer is 0 to negative to the left, 0 to the left. So next is we have the limit x approaches negative 3 to the right. So we have this 6 plus 2x over 7x minus 14. So we have this 6 minus 6 over negative 21 minus 14. So we have this 0 over negative 35, and we have this 0 to the right. So next is we're going to see if the limit negative 3. So we have this limit x approaches to negative 3. We have 6 plus 2x. Using this over 7x minus 14, so we have this 6 minus 6 over negative 21 minus 14. So we have this 0 over negative 35, and our answer is 0. So therefore, based on these illustrations and these solutions, the function f of x equals 6 plus 2x over 7x minus 14 is continuous at x approaches to negative 3. We have this letter b, x approaches to 0. So we will change the value of x as what I've read the function earlier. So we have this f of 0 equals 6 plus 2 times 0 over 7 times 0 minus 14 is we have this 6 over negative 14. So we have this 3 over negative 17 or negative 3 over 7. So we will try this. The limit of x approaches 0 to the left. So we have this 6 plus 2x over 7x minus 14. We have this 6 over negative 14. And we come up with 3 over negative 7 or negative 3 over 7. So we have this limit of x approaches 0 to the right. So we have this 6 plus 2x over 7x minus 14. We have this 6 over negative 14. We have 3 over negative 7 or negative 3 over 7. And lastly, we have limit of x approaches to 0. We have 6 plus 2x over 7x minus 14. So we have 6 over negative 14. And it comes to reduce it. We have 3 over negative 7. So we come out with negative 3 over 7. Since as we've shown in the solutions here, so we can say that the function f of x equals 6 plus 2x over 7x minus 14 is continuous at x is equal to 0. We have letter C, x is equal to 2. So we will change the value of x into 2. So we have this f of 2 equals 6 plus 2 times 2 over 7 times 2 minus 14. We have 6 plus 4 is equal to 0. So we have this 10 over 0 is we have does not exist. Nagkatawa ko. Function z equals 2z squared is z less than negative 1 and 4z plus 6 equals z greater than negative 1 is continuous or discontinuous at z is equal to negative 6. So to find out, we are going to replace the value of z to negative 6. So we have h of negative 6 is equal to 2 times negative 6 squared. So we have 2 times 36, so we have 72. So to find the limit if it's continuous or discontinuous, so we have this limit of z approaches to negative 6 to the left side. So we have 2 times negative 6 squared equals 2 times 36, so we have 72. So another is that limit of z approaches to negative 6 to the positive or the right side, so we will use this. So we have this 4 times negative 6 plus 6 is negative 24 plus 16, and we have this negative 18. So since this is not the same, so we can say that the function is discontinuous at z is equal to negative 6. So next is we have b is equal to z. b is z is equal to negative 1. So we have this, as what I said earlier, we're going to replace this to the value of z. So h of negative 1 is we have 2 times negative 1 squared, so we have 2 times 1, we have 2. Next is, we have the limit z approaches to negative 1 to the left, so we have 2 times negative 1 squared, so we have 2 times 1 equals 2. And lastly, we have the limit of z approaches to negative 1 to the right side, so we have 4 times negative 1 plus 6, we have negative 4 plus 6, we have 2. Therefore, since these are the same, as we've shown here in the illustration, so we can say that the function is continuous at z is equal to 1. Next is find all the points where the function is discontinuous if we have f of x 0, x squared minus 7, and 7, this. So first is we're going to have this x approaches to 0. So we will use 0 to replace the value of x. So we have f of 0 is equal to x squared minus 7. So we have 0 squared minus 7. So we come up with negative 7. So we have this limit of x approaches to 0 to the right side. We have x squared minus 7. We have 0 squared minus 7. So we come up with negative 7. So lastly, we have limit of x approaches to 0 to the left side, so we have this 0. So therefore, the x is equal to 0 is we can say that the function is discontinuous since they are not the same. So next, we have this x is equal to 7. So what we're going to do is we're going to replace the value of x to this. So we have this f of x is equal to x squared minus 7. We have 7 squared minus 7. Is we have 49 minus 7, so we have 42. So next is we have this limit of x approaches 7 to the left side, so we have x squared minus 7. We have 7 squared minus 7, we have 49 minus 7, so we have 42. Lastly, we have limit x approaches to 0 to the right side, so we have 7, so our answer is 7. Therefore, we can say that this is the function is discontinuous at 7. So, all in all, as we've shown here, we have that the points 0 and 7 are the points that makes the function discontinuous since they are not the same. Thank you.